Welcome to Mariners Powerhouse Team Review and Training Center. So, we will continue our lecture about the Norton's Theorem. So, this is part 2 of Norton's Theorem. Okay. So, we already discussed numbers 1 to 8. And now, we are going to discuss number 9 up to number 12. Okay. So, we are going to apply the Norton's Theorem in the Wheatstone bridge. No? This is what we call the Wheatstone bridge circuit. So, take a look here at our whiteboard. Okay. So this is our circuit. Take a look here. So we have a 90-volt source. Then we have a 30-volt source here. We have a 30 ohms, then 60 ohms, 24 ohms. Then we have a 12-ohm source here. So first, for number 9, find the Norton's circuit. Norton's resistance in the circuit shown. So we are asked to find the Norton's resistance. As we said before, that our Norton's resistance is just simply equal to the Thevenin's resistance. Okay? So take note of this. Our Norton's resistance simply equal to the Thevenin's resistance. Okay? Okay. So the Norton's or the Thevenin's resistance are actually what we call the open circuit resistance. These are our open circuit resistance. Okay? These are our open circuit resistance. So, what we're going to do here is to remove our load resistance RL and then short the 90-volt source. Okay, so we have here let us redraw our circuit here. This is the Wheatstone bridge. Okay, I will remove the load resistance RL. Okay, we have here our 30, our 24, our 60, our 12. Then, we have to short circuit our 90-volt source. Okay, so let us remove the 90-volt source and short circuit the two terminals here. Okay, so this is our point A and our point B. Okay. What we're going to do here is to stretch this point A and point B, and then what will happen is this is just a short-circuiting conductor. Okay, it's just like saying short-circuiting these two terminals. So one terminal and the other terminal is just like saying that short-circuiting the two terminal here. Okay, so let us do it now. So we have here our our 30 ohm resistor. Okay, so this is our 30. Okay, this is our 24. Okay, then we have our 60. We have our 12. And then, this point is this point. So, I will just stretch our conductor A here. So, this will be our conductor A. Or point A. This is our point A. I already stretched A here. Okay? And also for point B, I will stretch this conductor. I'll stretch this conductor. Okay? So, this is our point B. Point B. Okay? And then, this conductor is also this conductor. It's just like saying short-circuiting these 2 points here, that one. See? So we are asked to find the Norton's resistance. It's just like saying putting an ohmmeter here, that is our Rn. Okay, so this is our Rn here. What will be the measured value of our Rn? Take a look here, guys. Let's say we have here, this is point B, this is also point B, right? Point B, point B. This is point A, this is also point A. So take a look here. What will happen to our 30 ohm and 60 ohm resistor? They will just be connected in parallel because there are two common nodes here. This one common node, and this short circuiting conductor is just a common node. Always remember, if we have a conductor here, that is just equivalent to a dot. Okay? Always remember that. Okay? Now, I will redraw the circuit. This will be the figure now. Okay, take a look here. So the 30 ohm, this is our 30 ohms. And the 60 ohms, so this is our 60 ohms. Then we have the 24 ohms here. Then we have the 12 ohms. What will happen here? Take a look here. This is like the eye of Spider-Man. Okay? So, tingnan nyo yung mata ni Spider-Man. Itong 30 at saka 60 magpaparallel. This will become in parallel. Okay? And also the 24 ohm and the 12 ohm resistor is in parallel. Okay? So this is in parallel. This is also in parallel. Okay? So we can calculate now what will be the product over the sum of this branch and also the product over the sum of this branch. Okay? So this is easy to solve. So it's just like saying we have there will be two resistors in series here. Take a look here, guys. So we have 1, we have 2. Okay. So this is our Rn. This is our Rn. Equivalent to what? So let us calculate the product over the sum of 30 and 60. So 30 times 60, then divided by 30 plus 60 equals. The answer is 20. Okay? This is 20 ohms. What about our 24? 24 times 12 divided by 24 plus 12. So that is equal to 8. Okay? So we are seeing here, it's just a simple series circuit. Okay? Naka-series lang sila, mga kawerpa. Okay? So, it's just simply 20 plus 8, that therefore the answer will be 28 ohms. As simple as that. Okay? So, the answer would be letter, there you are. The answer is letter C. Okay? 28 ohms. That is simply equal to the Thevenin's resistance or the open circuit resistance looking back at the two terminals. What about now the Norton's current? Okay? What is the Norton's current? That is the short circuit current. Take a look here, guys. Take a look here. I have to disconnect our 2 ohm resistor here. Okay? I will redraw the circuit. Okay, we have our 30, 60, 24, 12 ohms. So this is the 90 volts. Then we have here point A and point B. Okay, I already removed the 2 ohm resistor here. I removed the 20 ohm resistor, the 2 ohm resistor here. So I removed that, and then the two terminals A and B, I short circuited that. So take a look here. Let's say we have here a short circuit. We have a short circuit here. Short circuit conductor here. This one. That is our I Norton's current. That is the Norton's current. Okay? That is the current that will flow if we are going to short circuit the two terminals, A and B. So take a look here, guys. I have to solve this. No? One method, I will use the, what method? I will use, well, it's up to you if what method are you going to use for this case. No? So, take a look here. So, ano kayang method ang gagamitin natin? No? So, it's up to you. Okay? So, bahala ka kung anong method ang gagamitin mo dyan. No? So, remember that this is shorted. Remember, this is just shorted. This one. I told you before that a straight line conductor or a conductor is just equivalent to a dot. It's just equivalent to a dot. Okay? So, we can have this. We are going to short this one. Take a look. Here. What will happen if I am going to short this? The 30 and the 24 ohms will become in parallel. Right? It will become in parallel. The 30 and 24 ohm will become in parallel. Magpa-parallel silang dalawa. Paano yun, sir? So, how is that? So, take a look here, guys. This point, let's say, is this point. So, ito yung point natin. As you see here, this will be the 30 ohms. This is the 30. This is the 24. The 24 ohm. Take a look here. This is AB. They are just one. AB. Okay? This point is simply our point A and B, or AB. The 60 ohm will become in parallel with the 12 ohm resistor. Here. Okay? Then this node is this node. Okay, I will have it like this one. Remember, we have the 90 volt source here. 90 volts. So this is our 60 volts. Then we have here our 60 ohms, I mean. We have the 12 ohms. Okay, that one. Take a look at this node A or B. This is AB. Sir, there will be no more IN here. No? Nawala yung IN natin. Hindi nawala yan, mga kawerpa. IN becomes missing here, sir. Let us have our IN. But how to do it? This is a network analysis. what I will do here is this one. Take a look. Take a look here. Remember that the 30, it becomes parallel with the 24. Okay, I will show that to you. I will make it very detailed for everybody. So, that one. This is the 30, and this is the 24. Take a look here. We have this point AB. I will just have a conductor here like this one. There you are. There is a conductor here, and then we have this one. Then our 90 volt source here. This is our 60, then this is our 12. What will happen now? What will happen? Take a look here. Take a look here. For this circuit, we have the 90 volt source, that is the total current. And then the current will flow through these two branches. And then they will meet again at point AB. So therefore, what is that current? Take a look here. Take a look here. This is a 90 volt source, okay? And then there is a node here. One current will flow here and the other current will flow here. And then, what will happen now? They will meet again. So, naghiwalay sila, magkikita ulit sila dito. No? Okay, kaya wag mawala ng pag-asa. Okay? Edit mo yun, ha? Yung maganda. Okay. So, dito may punto na maghihiwalay, pero magkakaroon din ng punto na magkikita silang muli. Hindi na yata tayo naintindihan ng mga Amerikano. Okay. The current will flow here from the source, and then it will separate into two here. But they will meet again someday. Okay? So, therefore, now, what is this current? What is this current? That is our IN. The short circuit current here. Okay? So, there will come a time, nagkagalit, ulit, maghiwalay na naman, but they will meet again. Okay? There is again a current flowing here. Okay? So, sir, what is our IN therefore? Take a look here. Is it the current that will be coming from the 90 volt source? Yes or no? This is this current here. Okay? Pinagtagpo. Okay? Tapos, pinaghiwalay, nagkita ulit, okay, nagsama, pinagtagpo. Ano yung kanta na yun? Oh. Pero hindi tinadhana, naghiwalay ulit. They will meet again. Okay? Okay? You see? You see? Therefore, sir, this IN is also this total current. How is that, sir? Okay, let us calculate, of course. Let us calculate. Let us calculate. How is it? 30 in parallel with 24. So, product over the sum. So, automatically, 30 times 24, then divided by 30 plus 24 plus 24. Equals. Okay, the answer is, I'll make it in fraction, 40 over 3. I will have an equivalent circuit here, guys. That one, and then this point is this point, so that is 40 over 3. Okay, and then this point. Okay, so we have here our equivalent. What is 60? That is 60 times 12, then divided by 60 plus 12. Plus 12. 60 plus 12. That is equal to, is this correct? 10 ohms. Okay, that should be less than 12, right? That is 10. That is 10 ohms. Okay. What is that current? They are just equal. The total current is just your Norton's current. The current flowing here. The IN, there's only one current flowing because they are just simply connected in series. Let us have first our total resistance here. Okay, I will just add. So we have 10 plus 40 over 3. That is equal to 70 over 3. This is 70 over 3. Okay, now, let us find our total current. What is our total current? By Ohm's law, that is 90 over 70 over 3. So that is 90 divided by 70 over 3. Equals. Okay. So we have here 90, we have 90, okay. Our total voltage is 90 volts, right? So we have a 90 volts here. Tama ba yun? 90, di ba? 90 ba o 120? Okay, I will double check the figure. I'll just double check. What is our okay. Oh, by the way, it is what? For Wheatstone Bridge. $90 ba yun? Yung sample natin kanina? 90. Yes, it's 90 volts, no? It's 90 volts. Okay, so we have 90 volts. Okay, let us consider this. We have 90 divided by 70 over 3. Okay, I'll just double check first. So we have 40 over 3. Okay, and then we have here plus 10. So that is equal to 70 over 3. Okay, so we have 60 times 12, then divided by 60 plus 12 equals, so we have 10. Okay, so we have this so therefore 90 divided by 70 then over 3. So the answer is around 3.86. I will show you another solution for this before we go to our PowerPoint. So I'll show you another solution. Okay, I will solve this using the Maxwell's mesh method. I will solve this using the Maxwell's mesh method. so that you will see two solutions, no? They should have the same answer. Okay, I'll just double check this one. So we have 30 times 24, then divided by 30 plus 24. That is 40 over 3. Okay, I will make use of the Maxwell's mesh method. Take a look here, guys. Take a look here. This is the Maxwell's mesh method. So I will introduce here the mesh. Okay, so we have mesh loop 1. This is loop 1. So I will head here as I1. Okay, this is our I1. Then we have here our mesh 2. This is our I2. Then we have our mesh 3, which is equal to our I3. Take a look here, so that we are very sure with our answer. So, by Maxwell's mesh method, I call this as the triple M, no? The Maxwell's mesh method, the triple M, Maxwell's mesh method. That is actually the mesh analysis. At loop 1, what is our equation for loop 1? Take a look here. Take a look here at our equation. At loop 1, so our circulating current, okay, I1 lives on the negative terminal of 90 volts. Okay? So therefore, that is positive, it lives on the positive terminal of 90 volts here. So that is positive 90 volts. Okay? That is positive 90 volts here. Positive 90. Okay? And then, again, no? So, automatically, our I1 is negative I1, then multiplied by the loop resistances. What are the loop resistances? It flows in the 30 and 60 ohms, no? So it flows in the 30 and 60 ohms. So we have 30 plus 60 ohms. 30 plus 60 ohms. And then we have to plus the 30, okay? So that is plus 30 multiplied by I sub 2. Okay? And then we have here plus, again for this, because this is a common resistor, we have 60 multiplied by I sub 3. That is equal to 0. Okay, let us simplify this, guys. So we have 30 plus 60, so we have 90, so that is negative 90 I sub 1. Okay? Then we have plus 30 I sub 2, then plus 60 I sub 3. So that is equal to, let us transpose the positive 90, it will become negative 90. So we have here equation number 1. We have equation number 1. Then for loop 2, where our I2 flows, the circulating current I2. So there is no current, there is no voltage source here. So therefore, that is negative I sub 2. Remember, this is at loop 1. What about at loop 2? At loop 2, we have negative I sub 2 multiplied by the loop resistances at this loop. So we have 30 and we have 24. So we have 30, okay? So 30 yun, ano? So 30 plus 24. And then 30 ohm is a common resistor. So plus, automatic, you have to add plus 30 times I sub 1. Okay? So there is no resistance here for I3 here. No resistance. So that is equal to 0. Okay? Again, negative I sub 2 multiplied by 30 plus 24 plus 30. So, plus 30 I sub 1. Okay? So, we have here 30 I sub 1. Then, we have minus. So we have this one, 54. Minus 54 I sub 2. Okay? I will have here 0. I sub 3 for our calculator. Okay? That is equal to 0. That is our equation number 2. Okay? This is our equation number 2. Then, at loop 3, at loop 1, 2, 3, it will be what? Take a look here, guys. Automatically, negative I3 multiplied by the loop resistances. So, we have 60 and 12. 60 plus 12. Then plus, this is a common resistor, the 60. That is common with respect to the loop 1 and loop 3. So therefore, we have here plus 60. Okay? So that is plus 60 I sub 1. That is equal to 0. Here. Let us simplify. So we have here 60 I sub 1. Okay? Then plus 0 I sub 2 minus. So this is minus 60. That is 72 I sub 3. That is equal to 0. That is equal to 0. Okay, that will be our equation number 3. Okay guys, let us make use of our mode 5.2 in our calculator. Take a look again. We have negative 90 equals, this is mode 5.2 by the way. Mode 5.2, so that is what now? So negative 90 equals, then 30 equals, $60 equals negative 90. For equation number 1 tayo. Negative 90 equals, then equation number 2 now. 30 equals, then negative 54. Negative 54 equals, then 0 equals, then another 0 equals, then we have 60 equals, then 0 equals, then we have negative 72. So this is negative 72 equals, then we have 0 equals, then equals. We can have the value for our I1, which is our X. Our I1 simply equal to 27 over 7 ampere. What about our I sub 2? What is our I sub 2 here? Ano ba yung I sub 2 natin? Another equals po. So that will be 15 over 7 ampere. Okay. Then we have here our I sub 3. So that is equal to 45 over 14 amperes. No? 45. So let us just, you can also have, okay, we can double check these values. No? Here, please close up this. Okay, so close up muna natin to. Okay, so please close up. Close up natin mabuti. Okay, so that our student can try the mode 5 too, and they can double check the equation that we have. Okay, so let us head now the current. So we have here our I1, so that is 27 over 7. Then our I sub 2 is 15 over 7. Then we have our I sub 3, that is 45 over 14. So take a look here at our figure. Okay, we have here our I sub n. Tingin ha, yung I sub n natin using the Maxwell's mesh method. Okay, so our I sub n simply equal to, okay, take a look here, that is going to the left. Okay, the current is going to the left, Then our I sub 2 is also going to the left here. So therefore, this is going to the left also, so that is positive I sub 2. But our I sub n, there is I sub 3 here, going to the right. So therefore, that is minus I sub 3. Okay? So let us head here. Okay? Take a look here, guys. So our I sub 2, we have the value 15 over 7. 15 over 7. Then minus. So this is minus. We have here our I sub 3. So our I sub 3 is 45. Our I sub 3 is 45 over 14. Okay, so we have here 45 over 14. So what will be our answer here for our I sub n? Okay, 15 over 7 and then minus 45 over 14. Okay, the answer here will be a negative 15 over 14. Okay, or just simply negative 1.07 ampere. Okay, we have a negative value. We have a negative value here for our I sub n. What do we mean by that? Because I only assume this current going to the left. Well, actually, this negative means you have a wrong assumption. Okay, there's no problem with it. So, meaning, considering the conventional flow of current, so your current I sub n must be going to the right. Okay, so papunta siya sa kanan. Going to the right talaga siya kasi naging negative. Anyway, what we want to get here is just the value. Okay, the magnitude, I mean. So take a look here for number 10. So our answer will be letter C, 1.07. That is our answer. Okay, looking at our first approach here, take a look here. I think it's not that applicable with this circuit. Okay, so I already double-checked this, no? I think it's not that applicable, no? In solving the Norton's current here. So, hindi siya naging applicable dito, no? So, because this point A and B, no? So, meaning it is just a point, no? Here, so, kumbaga, point lang siya. It's just a point. Is point A and point B, or these 2 points. Okay? It's just this point. Because this is just a node. This conductor is a node. We have 30 and 24. So 30 and 24 are just connected in parallel. Okay? So we have here 60 and 12 will also be connected in parallel because this is just a conductor. Okay, so conductor ito. So magpa-parallel sila dito. So, ayun. So I'm looking where I'm troubleshooting this approach, no? Okay? Where we committed a mistake.
Sir, baka yung 3016 series. Kaya.
No, the 30 and 60, they are not connected in series because this is a node. This is a node. Node kasi ito. No? Point A, point B. So, we are only asked to find the Norton's current here, the short-circuiting current here. Okay? The triple M method is more accurate. This is actually correct. This is correct. Okay? But looking here in our circuit, no? So, we have here a 90, no? The 30 and 24. So, we are getting this short circuit current here. This is a short circuit current here. What current will flow here? Okay, take a look here. I will have a current here because I said that there is a parallel circuit. This is this current and then this is current. Take a look here. Okay? Let's say we have a current I total here. This is I total. Okay? Kalimutan muna natin itong Maxwell's mesh. Okay? That's the second approach. Okay. Okay, what do you call this? I consider that IN is going to the left. I consider that already here. Okay? So, take a look here, guys. Take a look here. So, this is, we can make use of the Kirchhoff Current Law here. This is a different approach, but we can make use of this circuit. This circuit. Actually, we are already finished with the Maxwell's mesh. I just want to show here. Okay. So, there is a current here. This is current, no, at the 30 ohm resistor. And then we have the I sub n. I assume this is the I sub n. Okay. This is I sub n. Okay. Then, what is the current flowing here? There. Okay, I will make this current, well, I will make this as IA, by the way. This is IA. What is this current, guys? What is this current? What is this current, by the way? This current is IA plus IN, no? IA plus I sub n. Because the current entering is equal to the current leaving. See? Here. Okay? So, take a look here. Okay, may I erase this one? So, I will erase this. We are already finished with the Maxwell's mesh. I'm just going back with that principle. I'm just curious to that approach. Okay. Remember that our answer is 1.07. That is our final answer. 1.07. Take a look here, guys. We can make use of the Kirchhoff's law here. But this is quite complicated, so let's see this circuit. Okay? This circuit here. Okay. We have our IA, we have our IN, no? IA plus IN, so we have this circuit, this current, okay? Okay, so let us have our IB here. So ito IB natin. Gawin natin tong IB, mga kawerpa. Okay? That is our IB. No? I will erase first our IA, I1, so that you'll not be confused. We have here our I sub 2. Okay. There. Okay. Looking at our current here, IA, this is the current flowing through our 30 ohm resistor. So this is our IA. And this is our I sub B. Okay? Take a look here. We have here a current. Take a look, guys. Here, this one. The current flowing to our 60 ohm resistor. Okay? We use the Kirchhoff Current Law here. What is the current here to 60 ohm resistor? Let us assume first, we have this circuit. Okay? I will erase this I sub N before that we put. Assume first that this is also our I sub T. Yun nga, kasi di ba naghiwalay siya. It separates into two, then it combine again here. So if this is IT, this is also our IT. Okay? So, we have I at 60 ohm resistor. I will make use of the current divider theorem. By current divider theorem, we calculated for the value of our I total. What is our I total, by the way? So, ang I total natin is 90. So, that is 3.86, no? That is 3.86. So, that is 90 times 3, then divided by 70. Okay, so that is 3.86, our I total. Okay, let us solve our IA and IB. What is our IA, by the way? I total, what is our I total? 3.86. Okay, and then multiplied by, so we have our IA here. Take a look. Opposite resistance is 24. Over 24 plus 30. So that is equal to what now? $3.86 times 24 divided by 24 plus 30 plus 30. 24 plus 30. Okay, the answer will be our IA here is approximately 1.716 or okay, 1.716 ampere. Okay. Then what about our IB, guys? What is our IB? Our IB, again, that is also the same 3.86, the total current. And the opposite resistance of IB, which is 30. All over 30 plus 24. So we have 3.86, then times 30, divided by 30 plus 24. 30 plus 24 divided by 30 plus 24 times 30 divided by 30 plus 24. Okay, equals, so we have here 2.144 amperes. Okay? Okay, we already have A and B. A and B. Okay? Take a look here. So, what is the current to our 60 ohm resistor? By the way, what is our current to the 60 ohm resistor? Remember, this is again our IT. Okay? The current in the 60 ohm resistor is what? Take a look. That is, the current in the 60 ohm resistor is our IA plus IN. No? So therefore, it is IA plus IN. So that is equal to what? The current in the 60 ohm resistor, this is also our IA plus I sub N. There. Okay? So, we can have the I total, resultant current, 3.86 multiplied by the opposite resistance, which is 12, all over 12 plus 60. Okay? So, we have 3.86 times 12, then divided by 12 plus 60. 12 plus 60. So, the answer is 0.643 ampere. 0.643 ampere. Take a look here, guys. We have our IA. Again, what is the value of our IA? We calculate it for 1.716. I will transpose this. Take a look. Our IN will be equal to, we calculated already here, 0.643 amperes. Okay? Transposing positive will become negative. That will be negative 1.716. Okay, so we have 0.643 minus 1.716. There it goes. Okay. Negative 1.073. Of course, in our Maxwell's mesh method, we get also negative 1.07. It's just that because I use my assumption here going to the left. Again, the current really is going to the right. Meaning you just have a wrong assumption. There's no problem about it because you are only assuming that. Okay. See? So we already get now the value of I sub N. Actually, the total current is not yet our Norton's current. Our Norton's current is, I showed you here. So, still, nagamit pa rin natin to. No? We use this also, this circuit. No? Although, it really needs quite a deep, no? Medyo malalim na analysis ang kailangan dito. No? Ayan. So, ginamitan ko na ng Kirchhoff Current. No? I use the Kirchhoff Current Law here. So, there's no mistake here. It's just that I have to continue solving it. No? I consider the Kirchhoff Current Law here and the current divider theorem. Okay? So, it's up to you. What method are you going to use? Is that the Maxwell's mesh or this method? It's up to you. No? Okay? So, syempre, mas madali yung Maxwell's mesh, di ba? Mas madali yung Maxwell's mesh. But, this is a good analysis so that we have a verification. Because that is my attitude when I was in college, I solved. No? Just like what I've told you before. If there are our exam is 1.5 hours and I already solved let's say 5 problems for 1 hour. I already finished it for 1 hour. I still have half hour or 30 minutes. I will not submit my paper. No. I will not submit it right away. No. Just like my other classmate. Then after submitting, they will go to Grand Central, to the mall. No? Because that is our last subject. So, I will not do that. I will consume all the time. I will try other method because I want to make sure that my answer is correct. Well, we can go directly with Maxwell's mesh. We can get the answer right away. No? Okay? So, it's better that we have at least 2 approach. If you still have time, no? You have your college examination, if you still have time, no, may oras ka pa, ay, huwag ka muna magpasa ng papel, no? Do not submit yet your paper. No? You can try other methods so that you are very sure. You are very sure that you're correct. Okay? Para makasigurado kang tama ka. Okay? So, well, that will be it, no? Okay. We have some follow-up questions, by the way. Okay. Sige, so find the load current. Find the load current for number 11. Okay, again, for the load current, I will go directly, guys, with the formula. IL is equal to what? IN, then multiplied by RN, right? Over RN plus RL. Okay? Ano ba yung IN natin? Nakuha natin? Yun nga. Okay? I will make use of the positive, no? 1.07, then multiplied by Rn. Ano ba yung Rn na nakuha natin? Nga pala, ano ba yung Rn na nakuha natin kanina? Nabura ko yata. Okay, what is our resistance? We get 28, right? We get 28. Okay, we got 28 here. So we have here 28 plus, we have our RL. What is our RL, by the way? Is that 2? 2. Okay. So what is our IL equal to? So let's make use of our calculator. So we have 1.07, then times 28 divided by, well, that's actually 30. No? 30 lang yon. 30, okay, equals approximately 1. Kasi 0.9986666, no? So, approximately that is 1 ampere. Okay. The answer would be letter, in our PowerPoint, that is, there you are, 1 ampere. Okay, let us solve the last problem. This is very easy, the last problem. Okay. Find the load voltage. No, the load voltage simply equal to, okay, the load current, which is 1 ampere, times the load resistance, that is 2 ampere. Use your calculator. Okay, that is 2 volts. Okay, so the answer would be letter, okay, that's correct. Letter B. No? Okay, so that would be it for today, guys. So, thank you very much, no? So, thank you, and God bless you all. Thank you.